Greetings, the Astro 30 here yet again. Now, before I rebuild this power amplifier onto its new PCB, I want to address the issue that it has of what I consider a fairly high DC offset on the output. 150 millivolts doesn't sound a lot, but yeah, it kind of is. I was trying to ballpark it around about, the 60 millivolt range, which is more acceptable. So let's look at what causes the DC offset effect. So here we have a typical discrete amplifier design. The output stage is missing, but we have a long tail pair input stage. In this case it's a PNP, which then drives an NPN VAS or voltage amplifier stage. R1, R2 and R3 are really important when choosing the values which greatly affect the DC offset of the amplifier. Now, I found by reducing the value of R1 here down to around about 220 ohm, the overall DC offset of the amplifier was around about 100 millivolts. That is with R2 being 1K and R3 being 22K respectively. Now, as soon as I increased R3 to 33K, the overall DC offset also increased to 150 millivolts. Now, when adjusting the gain of an amplifier, the more you increase this value of resistor for the feedback resistor, the less overall negative feedback is being fed back into the input stage. Now, negative feedback also is a contributing factor to the amount of DC offset on the output. So we can reduce R3 to give a lower DC offset, but we also reduce the gain. So what we'd have to do to increase the gain again is decrease R2 to give us the gain we want. So what I'm going to do is, before I rebuild the power amplifier, I'm going to take this one. I'm going to remove the feedback resistor, the 33K, and I'm going to put a couple of little wires hanging out over the top. The 33K is just sitting there, just so I can connect some fly wires up to another potentiometer, and I'm going to set the potentiometer at around about 33K. Going to have a multimeter on the output and ground measuring the DC offset. We'll reduce the value of resistance by rotating the pot and have a look at what that does to the overall DC offset on the output. So I've unsoldered the resistor, so I'll just pop it out of the circuit like that. Find a pair of pliers. Don't know what that was. Remove the 33K. Now there is no negative feedback there at all. I should test the amplifier with no negative feedback and see what happens. Yeah, nah, I won't. Okay, so I've got a couple of cut off resistor or capacitor pigtails left over from another assembly, just poking out of the holes where the resistor was. So now I can connect a couple of fly leads across these 2 points across the potentiometer. I'm going to use a 100K linear pot. It's a good easy value there. Okay, so I've got a 100K pot wired here with one side double joined, so the wiper is joined to one end of the resistor and the other one's left open across my multimeter. Currently it's at 38 kilo ohms. Don't know how well you can see the meter, the light's a bit bright. So if I rotate my pot counterclockwise, my kilo ohms reduce. So I'm going to set it around about 33K thereabouts. It's very hard with a pot this size. That's not multi-turn, that is. There we go, that's good enough, 33.1. Now where it was connected to the pot, to the multimeter, I'm going to connect it across the amplifier, across the where the negative feedback resistor should be. Just hope that they don't short or anything strange like that. Turn the meter off, and now I need to connect it up to the power supply, and I need to hook up the meter across the output, obviously. Alright, with the multimeter across the output and ground, and the potentiometer across the negative feedback, I will say now, if you don't know what you're doing, don't try this at home. Anyway, I'm going to turn my power on. Okay, and so now apparently I've got around about 190 odd millivolt DC offset. So I'm going to reduce the resistance of the feedback. And apparently, by reducing it, I'm actually increasing the overall DC offset. That's interesting, isn't it? Okay, so I'll increase my feedback. I have no idea what value of resistance I'm at the moment. But I've reduced it right down to 50 millivolt. Now that means the amplifier will be operating at a humongous gain right about now. So I'll turn it off, and I will now place the meter across the potentiometer, and we'll see what its resistance is. More like 74k now. That's way too much gain. That's a gain of 75 when all said and done. So remember how I said the resistor going between the base of the transistor and ground after the negative feedback resistor is also important. So if I drop this down to say 10k, thereabouts, okay, and I'll get another potentiometer, and somehow I will try and get another set of leads in here where this 1k resistor is. Don't know how successful I'm going to be, and we'll play with the value of that resistance and see whether that reduces the overall DC offset, which in theory should. So yeah, I'm going to remove that resistor and get our another potentiometer set up here. Okay, so I've lifted the end of this 1k resistor, and I've soldered two fly wires to where the resistor is under the board. So this time I'm going to use a 10k resistor, variable pot. I'm going to join the two, one end and the wiper together, and leave the other end floating like that. Connect that across my multimeter in the ohm scale when I find the ends of the leads here. And this video may not be relevant to a lot of people, but it is good to actually see what's actually going on with the circuit. Now, currently we're at about what the original resistance value was, is 1k. So I'm going to decrease that so it's around about a k. It's about there, it's very finicky. Okay, and I'm going to connect that to the leads of our where the 1K is, I'm going to bring in our feedback potentiometer, which is set to 10K, across where it goes. Okay, and now I just need to hook up this into the volt scale across the output and ground. Hopefully we can still see the meter. Yes, we can. So this goes across ground. Hopefully that's not shorting, or else it ain't going to work at all. Connect up our power. Alright, so I'm going to leave my feedback resistor alone, but I'm going to play with the gain resistor. Turn the load on. Now currently with the values we've got, which is 1K and 10K, we've got around about 200 millivolt, a little bit high. So if I start reducing the value of this resistor, we're all the way 0, it didn't do jack shit. So I'll try increasing it. Nope, didn't do anything. So I will increase my gain resistor till I get around about 60 odd millivolt, and by increasing this, well, the feedback resistor, if I increase the gain resistor here, it's not having any overall effect, but it is going to be reducing the effective gain of the circuit. But as we can see, the higher resistance value that we've got, the better the DC offset is. So I'm going to say I've got 10K here, and I'm not sure what value we've got there. Well, if I rotate that all the way up to 100K, we've got bugger all DC offset. So 100 divided by 10 is a gain of 10, plus 1 is 11. So, but again, I can reduce this and it's not going to affect my overall DC offset. So, in conclusion, what it looks like for this design is I need a fairly high value resistance for feedback, and we adjust the gain by adjusting, well, in this case of the circuit, R2, which in the case of this circuit is this one here. So if we increased this to around 100K and then played with the value of this resistor to reduce the amount of overall gain, we'd get a lower DC offset plus a lower gain. So the values I plugged in, if it was 100K versus 4K7, we would be looking at, well, instead of guessing, we'll go 100 divided by, say, 4.5, gives us a gain of 22. Now, if I divided that by, say, 2K2, we'd have a gain of 45, so that's way too high. So I want to gain around about 31 to 34, so that would mean we'd need a resistor there of 3.3 roughly, which will give us a gain of 31 if we added 1 to that figure. Now also remember that DC offset is also attributed to the amount of power going into the amplifier. So at the moment I'm at the maximum of my supply, which is 30 plus minus volts. If I reduce the supply voltage down, we'll notice that the DC offset does actually fall a little. Not by much, but it does fall. Then it comes back up again. But if I increase it back up, we're still getting around about 9 millivolt. Or in this case around about a negative 10 millivolt. Which is fine. We're actually in the negative realms here. Of course, decreasing our negative feedback, the DC offset starts to come back up. So that means the increased negative feedback resistor, or increasing the negative feedback resistor, which is effectively reducing the amount of negative feedback going into the input stage, will greatly reduce the DC offset. I mean, we don't have to go that far, but a DC offset of around 0 is where you'd want it to be. So at the moment it is at 0. So it is very critical of the amplifier's design what resistor values you choose to get your gain. Plus it also affects DC offset, so it's very important that we choose the right values. So I know 100k at plus minus 30 volts, this gives me 8 millivolts minus DC offset, which is more than fine. But as I said, we need a gain of about 30, so this pot over here has to be set to around about 3K3. So I'm going to figure out what I'm doing here, disconnecting this, and I'm connecting it now across the pot instead. So in this case I'm at 1.6 kiloohms, so I can reduce that off. I mean increase that, I should say, to around 3K3. That's fine. And now I connect that back across the amplifier, and then connect the multimeter back across the amplifier's output, back on the voltage scale. Fuck you. Fucking thing. And reapply the load. And yeah, it comes up a little, and then it starts buggering off. So under 60 millivolts is where I wanted it to be. So does it still work as an amplifier? That's a good question. Let's turn it off, and I'll hook up the speaker across the output. Okay, I got a speaker, the craps 15 ohm speaker on the floor, connected across the output. Well, we still have a bit of a thump there. But yes, it still does work as an amplifier. But we've reduced the amount of negative feedback. How good the signal is on an oscilloscope, it shouldn't be any different to what it was to start with. But now I know with this discrete amplifier design what the values of the feedback resistor plus the gain resistor should be to give me a gain of roughly 30, but keep the DC offset fairly low. Did I say fairly? I mean fairly. I am now German, I just said fairly low. Now all that extra buzz you heard on the speaker was because of these leads just hanging out in the breeze here. Now I don't have a 3K3 resistor, so I can't actually make the change. Okay, so I've installed a 100K fixed resistor now as the feedback resistor. I don't want to work the board too much, but if I damage this board, yeah. Okay, so we have a much more acceptable DC offset of 30 millivolts and falling off. As the circuit stabilizes, it should drop off considerably more. And I've still got the original 3K3 variable resistor across where the 1K is. So I know that physically that's working okay. I don't know if I've reduced the amount of noise because I've installed a fixed resistor now or not. But I can always connect it up across the speaker and find out. See if that buzz is gone. It's a little bit more acceptable. But yeah, it's picking up most of the noise on these wires down here. Beauty. So I'm installing a 4K7, which will give us a gain of roughly 21, which is fine for this sort of purpose here, this testing purpose of this amplifier. I don't need to go any higher than that. I will on the final, just to get a gain of 31. Just to double check my values, 4.7 gives us, yeah, a gain of roughly of 22. So that's fine for testing purposes. So I'll hook the supply back up. Okay, turn the power on. And look at that. Now we've got about 40, yeah, not very high. It's certainly better than where it was, put it that way. And as it stabilizes, it starts to fall off quite considerably. So I'm actually happy with that now. So what happens if I touch the input? Nothing much on that scale. On the millivolt scale, we can actually see that it's jumping around as I touch the input, which is just basically a blurt. So I can see it's working as an amplifier. So that should have reduced our noise into the speaker. So I'll turn it off. I'll connect up the speaker again. Okay. There's still that pop there. There's not much I can do about that. But I can't hear any noise now coming out the speaker. And if I put my head down real low, I can hear a buzz, but that's probably coming from the soldering iron. Turn the soldering iron off. And there is very little hiss now coming out the speaker. Great. It's a lot less hiss than there was before. Okay, so I don't actually need to hook it up to an oscilloscope to see how good the output is. I can just hook it up across a potentiometer, the CD player and the input, and just listen to it. So sounds alright to me. Okay, so I'm going to leave that there. So I now know that what values of resistors to use, 100k versus 3k3, and I should still get a gain of around about 31. So DC offset on an amplifier is really about the choice of negative feedback resistor versus the gain resistor. The gain resistor is not so much important, but definitely the resistor on the input transistor. And for reference, I mean this resistor over here, that also controls the DC offset. That could probably be increased now, and it shouldn't affect the overall DC offset. But this resistor and definitely this resistor do affect DC offset. This resistor is not so important, but we can now reduce the value or increase the value of this resistor here to increase or decrease the gain respectively. So on my final amplifier, I'm going to use a 3K3 versus a 100K and have a nice little power amp with very little DC offset. There's still not much I can do about that turn on transient, that thump. That's just the way it is. But other than that, I'm now happy that I can reduce the overall DC offset. There's very little thump when you turn it off. So anyway, I'm going to leave this video here. And if you enjoyed it, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya. Thanks for watching.